Hey everyone, today I'm going to talk about sliding window technique. This technique is used to solve a problem efficiently based on a continuous subset of element. This technique will reduce the time complexity to O of n and space complexity to O of 1. In this technique, we use a fixed or variable size window to iterate over a data structure, typically an array or a Let's see how can we use the fixed size sliding window technique to solve a problem. Let's solve a question. To find the maximum sum of all subarray of size k. Given an array of integer of size n, our aim is to calculate the maximum sum of k consecutive element in the array. First, see the brute force approach. To find the maximum sum of k consecutive element in the array, we can iterate over every I and j, where I is from 1 to n and j is from I to I plus k. So this way we can find out the maximum sum of k consecutive element. But this solution will require the time complexity of n cross k, and it is not so efficient. So we can solve this question in O of n using a fixed size sliding window technique. To solve this question, we define a function find maxsum subarray that take two parameters, a vector of integer and an integer k, and return the maximum sum of k consecutive element in the array. To solve this problem, we define a integer I, initialize it with 0. It will keep track of the left pointer in the array, and integer answer give it some negative value, so that we our aim is to find the maximum, so give it some more negative value. And integer n, initialize it with the size of the vector, and integer sum, initialize it with 0. The sum will keep track of the current sum of the subarray. So to iterate, uh, then iterate over the vector using a variable j. This will keep track of the right pointer of the array, and take sum, add the value of aj to sum. This, as we know, this sum will keep track of the current sum of the sum array. So sum contain the sum uh, the of the I to j element in the array. So add the value of jth element to sum, and if j is greater than or equal to k, if j is greater than or equal to k, it means that our a window contain k plus 1 element. To make our window of size k, we need to remove the leftmost element. So subtract the value of ai and increase our leftmost pointer by 1 by incrementing I plus plus. And then if our the window size is k, then we need to update our answer, that is ans equal to maximum of ans comma sum. And after iterating up to the n index, we need at the end we need to return the answer, and here our answer contain the maximum sum of k consecutive element in the array. Let's do one exercise to find the maximum sum of all subarray of size 3. Here k is 3 and we are given a array of integer of size n with the element are 1 4 5 7 1 3 6, and we need to find the maximum sum of all subarray of size k. So let's start. And here let's start when our j is 0, then uh, um, our window size is not 3, so we do nothing and go move to the next index. And here j is 1, so as we can see that 1 sum of 1 and 4 is 5, but our window size is not 3, so we do nothing and move to the next um, index. And here our window size is 3 and sum is 10, so we will update the sum as our j is less than 3, so we didn't remove any element from the window. And in the next iteration our index j is 3, so our window size become 4. Then so we need to remove one element from this window, so just remove the leftmost and the element, that is the element present at index 0. So just remove this, and now our sum is 16 and we are going to update our answer to 16. And in the next iteration again our window size increase, so remove the leftmost element, that is the element present at index I. And now our sum is 13, so we going to compare the ans of maximum of ans and sum. So our current sum is less than sum, so we do nothing, our ans remains 16. And again at we when we go to index 5 our window size increase, remove the leftmost and element, and now our sum is 11, so we do nothing as the sum is less than ans. So and in the next iteration we go to next index, and here our sum become 10. As we can see our answer is 16 and sum is 10, so we do nothing and go to next one. And now our j becomes 7, so we going to end our iteration, and then at the end of the iteration our answer is 16, so return the 16. And as we can see that we are able to find this solution in o of uh, in time complexity of o of n and space complexity of o of 1. As you observe, there are some steps that should keep in mind using this fixed size sliding window technique. First, find the size of the window required, say k. compute the result for the first window and include the first key element of the key data structure. Then use a loop to slide the window by one and keep computing the result window by window. Don't forget to practice this concept of fixed size sliding window technique, and in the next part of this video I will discuss about variable size sliding window technique. So keep practice, code, compete and win.